A satellite weighs 200 newtons on the surface of Earth. What is its weight at a distance of 1 Earth radius above the surface of Earth? So if we consider the distance between the masses on the surface of Earth to be 1 Earth radius, so if this is our satellite here, of course it wouldn't be that big if this was drawn to scale. The satellite would be 1 Earth radius away, and if we move it a distance of 1 Earth radius above the surface of Earth, so that distance again, then in total it would be 2 Earth radii away. Now we know from the law of universal gravitation that the force of gravity is equal to the gravitational constant times the mass of one object times the mass of the other divided by the distance between them squared. So in the first case, where the satellite is on the surface of Earth, the distance between the masses is the radius of the Earth, and that will be squared. So this equation gives us that the force of gravity is 200 newtons. So I'll label this force of gravity with a subscript of S to indicate that it's on the surface of the Earth. Now we'll calculate the new force of gravity when the satellite is an additional Earth radius away. So it'll still be G. The masses will remain the same. We'll have the big mass of the Earth, the small mass of the satellite. But instead we'll be dividing by 2 times the radius of Earth, and that'll be squared. So the distance between the centers of the two masses is now 2 Earth radii. So this is equal to G times mm over 4 times the radius of the Earth squared. So if we distribute that exponent, the 2 becomes a 4, the radius of Earth becomes the radius of Earth squared. If we pull out that 4 from the denominator, we'll have 1/4 times Gmm over the radius of Earth squared. And we actually have a value for this expression. It is 200 newtons. So this here is the same as what we have in the brackets here. So we can substitute the value 200 newtons in. So we'll have 1/4 times 200 newtons, which is equal to 50 newtons. So that would be the force of gravity acting on the satellite if we moved it an additional Earth radius away from the surface of Earth. So it would be 50 newtons. And that's because, as we see from the universal law of gravitation, the force of gravity, or the weight force, is inversely proportional to the distance between the masses squared. So if we double the distance, the force of gravity will be 1/4 what it was before. If we triple the distance, it will be 1/9 what it was before, so on and so forth.